Hello, hi, my name is NMK30303 and I will be presenting about assignment 2, TinyOS. My number is 221301705. Okay, what is actually a TinyOS? Before we continue on that, I'm going to explain what it is inside my presentation today. This is my table of content. I have 4 content on this presentation. First is the topic of this presentation, which is explanation about function of TinyOS. Second is elaboration about topic, elaboration about goals, aim of TinyOS. Third is a 2 real-world example of TinyOS. And fourth is the content of TinyOS example, which I will including a functionality, diagram, and ways to enhance the TinyOS. As I said, what is actually a TinyOS? Okay, the targeted system of TinyOS is designed for resource-constrained embedded system. It is particularly well suited for wireless sensor network and Internet of Things. The specific requirement of function TinyOS is the features are tailored to address the specific requirement of this system. As I said, the specific requirement cater any of the system needed. TinyOS also revolves around providing a lightweight, modular, and energy-efficient operating system tailored for the unique challenge. Next, this is the general term for TinyOS aims and goals. Before I'm going to pursuing the specific aim and goals, I'll be explaining the general term for it. The aim of TinyOS is to bridge the gap between powerful software and device with limited resource. The goal is to enhance the overall performance and applicability of technology in the domain of wireless sensor network. Let's go through what is the aim and the goals of TinyOS. There are 4 aims of TinyOS. The first aim is for resource efficiency. As we know, TinyOS is designed like a lightweight design. It is aimed to minimize memory usage, energy consumption, and processing overhead to ensure optimal performance on device with limited resource. Next is promoting real-time and reliable operation. This aim is solely proposed for time-sensitive applications, such as medical device, that aim to ensure immediate reaction to critical situation. Its efficient scheduling and communication protocol prioritize such critical tasks. Because in medical device, we need to keep an eye to vital signs like heart rate. A quick response in TinyOS kicks when something important happens, ensuring that the healthcare or professional can act fast for emergency to help the patient care better and safer. Third is reliability in harsh environment. TinyOS aims to provide a reliable platform for application in a harsh and dynamic environment. This is because extreme weather conditions or in industrial setting, where interference and environmental factors can impact the performance of the network. That is why the aim of TinyOS to overcome those harsh environments. Last aim is for reliable data delivery. The aim is to ensuring the accuracy, timeline, and consistency of information exchange in today's ever-connected world, ensuring that the sensor data reach the central hub or gateway accurately and without delay is crucial for data analysis and decision making. Next is the goal. Before that, the goals and the aims are typically just the same, but I'm just separated for to be clear. The 3 goals that I found is scalability. Scalability is the things that design in TinyOS, allowing TinyOS to be used in various deployment scenarios, from small-scale sensor network to large-scale deployments with thousands of nodes. Later, we will learn what is the nodes and why it is important for small-scale sensor to large-scale deployment. And this scalability is crucial for accommodating diverse application and network sizes. Next, TinyOS. The goals of TinyOS is also to get the responsiveness, the quick responsive from the TinyOS. This is we can relate it with the real-time application because TinyOS provides support for real-time requirement, allowing developers to specify the timing constraint of tasks. TinyOS also event-driven architecture and non-blocking I/O technique ensure immediate response to critical situation. The easiest example is the medical device. It has TinyOS in it to be better to help the patient without forgetting anything. The last one is reliability. TinyOS robust communication protocol and error handling mechanism minimize data loss and ensure stable operation. Data transmission and system operation must be dependable, especially in applications like medical device or industrial control system. Okay, this is the two real-world examples that I chose. TinyOS enable low-power wireless sensor for the real-time environmental monitoring, showcasing its simplicity and energy-efficient design. It means that real-time environment monitoring, just now I explained it, I take it in about medical device. Now, I use a fall detection sensor as a real-time environment monitoring. Later in the slide, I will explain you more why it is a real-time environmental monitoring. And the next sensor that I use is underwater sensor network. As a term in this sensor, I use AUV, autonomous vehicle, because the vehicle includes too many sensors that has TinyOS in it. I'll explain it later. Okay, next, fall detection functionality. Okay, it has its own functionality because it's a technology that sense when the person is falling. It alerts caregiver or emergency to alert when the person is fall. It's for people who might have trouble to getting help for themselves, like older adults or those with health issue. This is fall detection system, which is fall detection system is a wearable device that I can give examples such like a Apple Watch that has fall detection itself in it. Fall detection system collecting data using an accelerometer to constantly measure motion and orientation. Then it will analyze data to apply the algorithm to detect sudden change in acceleration and posture indicative of a fall. Next, the trigger alert is a button, if there's even a button, or sometimes it will not have a button, sometimes it's just alert the caregiver. Point is to alert the message to the designated recipient if a fault is detected. That's a kind of flow detection for fall detection diagram. Next is the fall detection enhancement. For fall detection enhancement, the first thing that I noticed is the improved algorithm, or I could say the smarter algorithm. It means that the algorithm is considering the context. It can distinguish falls from daily activity, like between a person is falling or someone is bending over to tie their shoelace. This way, the false alarm are minimized and the device responds more accurately to real fall incidents. Next is user personalization. It allows user to adjust sensitivity and parameter based on individual needs and activities. It means that if someone is more active and engaged in the activity, it might involve a quick movement. They can set the device to be less sensitive to avoid triggering false alarm. Next is the multi-sensor fusion. The function is to combine data from additional sensor, such as gyroscope, which is the function to provide information about the orientation and rotation of the device. And the pressure sensor is to detect change in altitude or body pressure for more robust fall detection. Okay, that's enough for fall detection sensor. I'm going to go into underwater sensor network functionality. Okay, what does underwater sensor network functionality do? This is to monitor underwater environments such as temperature, salinity, pollution levels, and marine life using sensor nodes deployed in the water bodies. This is why sensor nodes that are so important in TinyOS. Sensor node, the function is to collect and send data to the surface that act as a gateway. I'll explain it more later. Okay. The next function of underwater sensor network is to enable oceanographic research, pollution tracking, habitat monitoring, and underwater infrastructure monitoring. Okay. I'll show you the flow of the underwater sensor network diagram functional. The first step is for the sensor to collect data. The list of sensors that I put is temperature sensor, which detect the water quality, and the second sensor is the DO, dissolved ocean sensor, pH sensor, turbidity sensor, nitrate sensor, and hydrophone sensor. All of these 5 sensors is measuring a marine life. After the sensor had the data, it will send the data to the sensor node. Sensor node function is to collect data and transmit data to the receiver buoy. This is what I say when the receiver or buoy on the surface that act as a gateway between the underwater network and the outside world, because it receives data acoustically from the underwater and then relies it to the satellite or network for the analysis and processing. The same thing happens to the salinity sensor, except the salinity sensor is studying the salinity influence on the marine life. It keeps track of the water salinity by measuring its electrical conductivity. Knowing that the salinity is crucial for studying ocean currents, tracking freshwater plants, and understanding how salinity levels impact different marine creatures. And then the sensor is going to send the data to the sensor node. And as usual, sensor node will send and collect the transmit data to the buoy. It will be analyzed by the person in charge in the surface. Next is the underwater sensor network enhancement. Okay. Underwater communication. It means that develop a reliable communication protocol to overcome challenge of signal attenuation and propagation in the water. Sometimes the signal in the water is too high. It cannot be detected. So I think that's the thing that need to be enhanced for the communication between underwater and the surface communication. Next is energy harvesting, exploring energy harvesting techniques such as water current or thermal gradients to extend lifespan of underwater sensor nodes. Okay, that's all from me. Thank you. Thank you, madam.